science of universal ancestry, which brings us to where we come from, where are we going, and also wondering about the age-old question, what is actually good? Joshua, a pleasure to have you as our keynote speaker this month. Please feel free to take it away from here.
Great, thanks for having me. I'm going to put up my slides here. That was a great introduction. So first of all, thanks for having me here, and I'm looking forward to the conversation with everyone. I really wanted to look at how we might learn a little bit from medical ethics and some of the stories that happen there, and what that can tell us about good AI and how we could get to good AI. Sang gave a great introduction. Some of the key things to know about me, so I just switch over to the slides section here too, is that I'm a professor at Washington University in St. Louis, which is a little bit away from Seattle. It's in St. Louis, not the Washington or University of Washington near you. Also founded Peaceful Science. It's a nonprofit that's really doing work to really build trust between scientists and the public. So my research really is focused on computational work to solve problems at the intersection of medicine, biology, and chemistry. These are two of the grants that we have that are about to finish, and then I have a couple more from the NIH where we've been looking at, you can see molecules here, and you can see colors behind them. And what's really going on is that there's an artificial intelligence algorithm there. It's a type of deep learning algorithm that's able to predict how molecules become toxic. Like this one becomes toxic, this one doesn't. And actually predict the mechanism by which it becomes toxic through a bioactivation pathway. And we also, this is my son when he was a little kiddo. This other grant was looking at how this is different in children. So one's looking at toxicity in adults, the other one's looking at toxicity in children. So we've been really fortunate to be able to make a lot of advances in how and understanding how this works and really building artificial intelligence algorithms to really guide drug development and make medicine safer. I've been really fortunate to be part of that. There was some talk also about my book, The Genealogical Adam and Eve, which I'm not going to really talk about very much now, except for just kind of point to some of the breadth that I've been involved in. This really has very little to do with artificial intelligence at first glance. It's really looking at origins. But the thing that's interesting about both AI and origins is it really brings us to that grand question of what it means to be human. And that's why I'm really interested in both of those and how I engage both of those when I engage the public. Another another project that we've been working on, and we have a couple grants on it too, is looking at how AI is used for kidney transplants. So this really starts to get into the medical area a lot more. So this is a section of a kidney right here, and then this is zoomed in right here, and you can see circles here. It's not really clear what they are from where they are here, unless you're really trained. But they're parts of your kidney that actually do a lot of the filtration of your blood to produce urine initially. They're called glomeruli, if you remember back from high school biology. And what this algorithm is able to do actually is be able to pick out all the glomeruli and also identify which ones are normal and which ones are sclerotic. That's the blue ones here. Sclerotic means just scarred. And it's able to do this not on fixed sections, but frozen sections like this, which are really done. So why this really becomes valuable is it turns out that when there's a kidney, this is a picture of a kidney surgery right here. When there's a kidney that's available for donation, what they do is they actually cut a small piece of it off and put it on a slide like this and send it off to a pathologist. The pathologist has about 30 minutes to look at it, to look at around 100 of these little glomeruli and count up and figure out what percentage of them are sclerosed and what percentage of them are normal. It ends up being a really key part of the decision-making process they have about whether or not this kidney is safe enough to transplant. And so we published a few papers on this, and we actually have it working strongly enough that it's starting to come in, and we're going to be able to bring it into clinic really soon. And with that, we start to really wonder and ask questions about those ethical questions of AI, like when is it actually safe enough to put into practice? Should an AI be able to overrule the physician's assessment of that kidney? And how do we test it and follow it? There's a whole ton of ethical questions that come up. And there's more, too, that I haven't even really gotten into, but I will in a moment. And the thing that I really noticed, though, is I've really been applying AI within medicine, is that these sorts of questions are actually far more worked out in medicine than they are in the world of AI. And I think that there might actually be some real value in looking at the history of how that happened in medicine and seeing how much of that could apply to us as we think about AI. So what I want to talk to you today about is the Tuskegee Syphilis Study from 1932 to 1972. This is Black History Month, so it makes a lot of sense to talk about this for a lot of reasons. But it's really one of the key signal things that happened that changed everything in medical research. So syphilis is this, if you can see it right there, it's that spiral-shaped thing in the electron micrograph, the gray, black and white right there. Can you guys see my arrow? I'm not sure if you can. Well, whatever the case, it's right over here on the left. That is what syphilis looks like. It's an STD, sexually transmitted disease or infection. And here you can see a special stain which makes them stick out, and you see all these little corkscrew things. That's classic. That you only really see that with syphilis. And it has 3 different phases. This is like in a second phase. It'll produce this horrible rash often in people. There's also, it can produce blindness. It can cause infertility. It's a pretty horrible disease. It doesn't hit you all at once. The very first infections are very mild. Usually, some people don't even notice it. It's really only after time, when it reactivates after a latent phase, 2 or 1 or 2 times after that, where it starts to do some pretty horrible stuff. So, what was the Tuskegee Syphilis Study? Well, it started in 1932, and what happened is they wanted to study what would happen for the natural history of untreated syphilis. And the rationale was that, well, let's get a group of Black people, and we'll offer them free health care from the government. So this is run by the Public Health Services. And it was also done in collaboration with a historical Black college, Tuskegee University. It's called the Tuskegee Institute at the time. And they recruited 300 Black men. 201 of them did not have syphilis. 399 did have syphilis. And they decided to follow them with an offer of free medical care. These were really poor Black people in middle of the segregated South, and to give them free medical care and access to that. And so they trusted the researchers, and they took part in it. The only thing is that they didn't tell the participants that had syphilis that they had syphilis. And so this led to, I think, around over the 4 decades that the study went on, where they just sat there taking care of them, but not treating their syphilis. It's totally treatable. They could give them a course of antibiotics and it'd be gone. But instead of doing that, they just watched to see what would happen. And over that time, there was, I think, 120 people ended up dying for syphilis-related deaths. Several of their wives ended up getting infected with syphilis. There was 19 babies born with congenital syphilis. There was several people that became infertile, several people became blind. All of this was totally preventable. And it didn't happen. It wasn't one rogue researcher. There was several people involved from the very beginning with it. It proceeded underneath the leadership of several different public health services directors who knew about it and just didn't say anything. And it was really a whistleblower in, I think, 1972 that brought it to the public, and then it ended then. And when people actually looked to see what happened, it was really, really surprising. I think one of the most horrifying things actually about this particular study is that so many people were involved and that just didn't have a troubled conscience. It never really struck them that, hey, maybe this isn't really the right way to treat people. Maybe we're violating people's trust. They just did that. Now, not everyone knew the whole story about what was going on, but there was far too many people that did know the whole story who just didn't say anything. So that's what happened. 40 years. It's still hard to put my head around that for how long that went. Now, when it did come to light, it was a major event. There was legislation passed, and there was a commission that was launched that operated for about 5 years. It's called the National Commission for Protection of Human Subjects of Biomedical and Behavioral Research. They made several reports and recommendations, and there's 2 particular ones I want to talk about. One is that they suggested making institutional review boards, which we're going to talk a lot more about. That was the second to last report they had. You can see the title page right here on the left. The second one is called the Belmont Report. You can see that to the right here. And they also made a large number of recommendations, too, really focused on things like informed consent. And this had a dramatic impact on health research really across the world. Basically, pretty quickly, a lot of other countries adopted very similar guidelines, and it became such that you can't actually do medical research right now at all without engaging an institutional review board. It's not optional. It's something that is bigger than any country right now. Even if the United States didn't have this law anymore, it would still be required of us. Even if you go to another country, it's required. And really what has happened is that it's become a very strong institutional change. Institutions has to do with systems, and it's not about just our own personal intent. It's not merely telling people, oh, you just need to be more committed to the Hippocratic Oath. All the doctors involved were far more committed to the Hippocratic Oath at the time, because that was a big deal in medical education, than they are now, because it's not that big of a deal. People had a very strong personal sense of ethics in the past, but that wasn't the issue. The issue was actually a lack of an institutional way of enforcing ethics. So that's what institutional review boards are, and I'm going to talk about that more in a moment. But then secondly, with this idea of informed consent is starting to establish actual ethical guidelines. One of the really key things to take away is that right now ethics is bigger than science, and it's bigger than China even. I don't know if you remember just a couple years ago, there was the very first CRISPR baby reported by this researcher here. You see the picture here. His name was He Jiankui. I don't know how to actually pronounce his name exactly right, but he basically edited two babies to be resistant to HIV. Their mother actually had HIV, and the idea is that this would protect them. The motivation behind that from a medical point of view is very, very poor. There's other ways to prevent HIV that make a lot of sense. The technology wasn't really ready for it. It can really cause a lot of damage because there's a lot of off-target effects. But yet this guy still did it. He did it outside of an IRB process, and it's really important that China decided to actually put him in jail for 3 years. And that sentence came about a year ago. This is important because, it's something where China could have tried to actually kind of take a loose hand and let it go. But I think what really became clear is that, we really need to handle this with great ethics, because there's a lot of good that can happen from doing CRISPR editing of humans. But if we don't do it ethically, it's going to ruin it for everyone, and no one will trust it. That's why everyone came down so hard on them about this. And it encourages me to, in the sense that, it's very hard to be a mad scientist right now in medicine and go off and do crazy stuff that no one would approve of, because really everyone knows that you really do have to act ethically, and you can't just do it by yourself. You actually have to have external people reviewing what you do to make sure it's ethical. All right, so what are the lessons? There's two possible lessons you could take from this. One is informed consent is what we really need. I really think that that's not the primary way to focus, and I'll talk about that for a moment. But the second one, which I do think is the right lesson, is that institutional review boards is really something that we need to be thinking about for AI. So why not informed consent? This is a great cartoon I found. It says there's a guy here with a cell phone, and he has a drone up there. And he says, I don't remember agreeing to a surveillance drone when I installed your company's app. And it says, didn't you read the terms of service? It's right after the cavity search. And there's a person doing cavity search. Well, here's the thing. It's very hard to get, informed consent in a meaningful way for complex things. We all see the terms of service, and most of us will flip through it and without actually, reading it closely, and we click yes. But that doesn't somehow give companies the right to do unethical things with what we have actually given them. One of the things that I teach ethics occasionally at my medical school. We all have to rotate through it as professors. Last time I taught, there was a group of students there, and we talked about the Tuskegee experiments, and I asked them, what went wrong in the Tuskegee Syphilis experiment or study. And one of the students, because they know about the Belmont Report, and it's kind of like the rote answer, that's why they're saying it. They said, well, the problem was that the researchers didn't get informed consent. I said, really? You think that that's the problem? The problem is that they didn't ask these people whether or not they could lie to them about whether or not they had syphilis. That's not the problem. It would have been great to get their informed consent, but there were so many profoundly wrong things that happened there that to reduce it merely to informed consent really misses the point. Here's another reason where it fails that is actually fairly important. So our algorithm that we're using to train kidneys it requires us to have training data like this that are from actual people who are donating kidneys. Okay, these are people who died, right? And most of them have died, not all of them, but most of them have died. And we're getting the kidney, and then there's actually an assessment made about them. It goes into the clinical care that way, but then we actually get it after the fact. We look at it, we have a pathologist annotate it, and then we build an algorithm based on it. We don't actually have consent from the patients to do it. And you could argue, well, that means that you shouldn't do it. But, we've actually done studies where we've gone back and actually talked to people about discarded samples and asked, well, if there's a way to use all these discarded samples and an image like this, and actually help other patients, would you want other scientists to do it? And almost uniformly, people will say, yeah, of course I would want them to do that. Of course I'd want them to use that information to help other patients. It's just that when this actually happened in the first place, when they actually collected these samples, people couldn't conceive of the research that we're doing with it now, so they never could have actually asked for informed consent. But is it ethical to use it or not? Well, in a lot of ways, it would be unethical not to use it because we're actually helping patients with it, and it's doing no harm. And in fact, there's specific rules about how this is really handled, such that it's actually waived research because it's not identified, because it doesn't actually involve treating any of the patients for whom we're actually getting this data from, and most of them are actually dead already. We can't actually do harm to them. So for that reason, it's called waived. That means that we can actually do quite a bit with it, even though we don't have informed consent. That just points to another way that informed consent fails. If all you care about informed consent, the problem is that you can still do a lot of really unethical things under the cover of informed consent that aren't ethical. And you might actually be stopped from doing a lot of things that are really important to do because you don't have the right consent for it. So there's a lot of problems with thinking about it from that point of view. Okay, so what about IRBs for AI? I want to explain specifically what that would mean and give you some examples of how that plays out. First of all, it'd be required review for all projects at all companies. It would not be something that would happen in an individual effort. It wouldn't be like the Google effort for IRBs. It would be something that would happen really across the spectrum. The type of thing where ethics would have to become bigger than AI in the same way that ethics is bigger than science right now. Usually these are independent. Well, they're always independent boards. Sometimes they'll be, for example, WashU has several IRB boards specialized on different types of science. And the independence comes from the fact that they actually are required to include community members. And for particularly challenging cases, they'll be sure to include patient advocates as well. So the FDA requires this also of pharma companies when they run research. So it's very common for a couple patients that have the disease or even on the study to sit on, or who might be on the study to actually sit on the institutional review board and ensure that everything being done is ethical. These boards have institutional power. They have the ability to unilaterally stop a project from proceeding. Basically, you cannot do research on humans at WashU, for example, without having an IRB. And it extends beyond that. My wife has a startup company where she is doing research on humans. It's a simple thing. It's just basically a handwriting app that they're going to have kids use, right? But it's research, and it's partly funded by the NIH. And she actually has to hire an IRB firm that came in and had an institutional review board for her work. And that study, they had to go through that. There was objections from the IRB. They had to come back with the responses to. And then once it was clearly established what was being done, and it was clear that it was ethical and no one was being harmed, that's the only way they were able to proceed. And in fact, if they collected data before that happened, that data would not be usable in actually making some of the claims they want to and some of the analysis they want to do. Another really key thing is that it can't be dissolved by a single company's leadership. It would be a New York Times, Wall Street Journal level scandal if WashU got upset with an IRB board's decision and decided to dissolve it. It just would not happen. People would be, it would be a major problem. Google had an ethics board. It wasn't IRB, but they just had an ethics board. It lasted for just a couple months, and then they realized it was going to be a bit of a problem, so they just dissolved the whole thing. that's not what happens in the IRB. Part of what happened, actually, it was actually legally required at first that you couldn't do any human research unless it was actually that way. But like I said, even now, if we got rid of the law, it would still be required because it has now become basically the cultural expectation and the institutional standard. And also there was a lot of work done in developing clear ethical principles for guiding decisions. And that's what an IRB is. And so what would that look like if, for example, this was instituted for AI? It would be the type of thing where, Google would actually have several internal boards that had external members, of course, or whenever they were proposing a project to do using artificial intelligence or using stuff that would just be deployed by software across large numbers of people, and same thing for Facebook, that there would be a group that looked at it and said, is that actually ethical or not? And if it isn't ethical, are there ways to make it more ethical? Or is there ways to mitigate the harm to people? And there will be people who are not incentivized to do anything other but to be truthful about that and to work that out. And they would also be unmuzzled to go public with things if they thought there was issues. And it wouldn't be at the high level of just having like a group of 10 people that report to the board of directors. It would rather be on a much lower level. So when any individual engineer came up with an idea, they'd have to run it by an IRB board before deployment at large scale. That's what it would probably look like. And that if that became something where it was actually expected of every company to do before they brought things to market at large scale, I think that would be good. That would actually prevent a lot of things. I think the issue right now for AI is we haven't had yet anything quite like the Tuskegee experiment. But it could happen, and it maybe will happen. Maybe it already has happened. When that comes to light, there could be a lot of legislation behind really fixing this. But I think it'd be better if we actually found a way to advocate for that to happen a lot sooner. So that's the big stuff I wanted to share with you, and I think I'm really curious to hear what everyone's thoughts are on this and any questions you guys have. What's your thoughts? Let's see, there's a raised hand and some questions. I also want to hear how AI can make medicine more ethical, Sarah Armstrong asks. That's a good question. I think, I think what we really care about as medical doctors is we really want to give patients the best care possible. We want to do it in a way that really minimizes risk and really maximizes benefit. And so when we can actually get to points where AI can do better than physicians, I think that's a point where there actually starts to become ethics involved about whether or not we're actually going to bring it to practice or not. So we're seeing that actually in the work we're doing with kidney transplants. We can actually show that the AI can actually do better than a pathologist can with more accuracy at really measuring certain things. And so I do think there's going to be a point where we have to ask, is it ethical not to use the AI with it? We're kind of on the cusp of that. There isn't really anything out there yet where that's really become the dominant model, but that's really where we're at the cusp of for that. So someone had a question? Gang is on.
Yeah. Can you hear me?
Yeah.
Yeah, I have two questions. One is that, there's no doubt that, we need AI is such a, fundamentally so important area that, has so much influence in the future of human beings. So we need, government regulatory policies on that. But my question is that, it's probably is in the medical field is probably we have come to the strong consensus in terms of what is ethical, what is not ethical. But in AI, especially when you come to AGI, which is artificial general intelligence, the opinions are very diverse. People don't come to agreement to what is ethical, what is not ethical. For example, in the Google and the Facebook are in the camp saying that no, this is not going to happen. The AGI is not going to happen. So therefore, we don't have to worry about whether AI will eventually do substantial damage to the human race. But there's people in other camps saying, well, this.
So you said AGI. You're talking about artificial general intelligence. Well, I would say that there's a lot of ethical issues, even if AGI is never going to happen. There's a lot of ethical problems with misapplying AI, right?
Yeah. So I'm just saying that probably is much more challenging because in the ASI area and in artificial specific intelligence, I think there's consensus there. Basically, in other areas, AI can help human beings do the job much better than what we're doing now. But there's a very diverge opinions about what is AGI and whether this, from that's one that is not a very concrete agreement in terms of what is ethical or not in that area.
Yeah. We got to be really clear, though, here. There's an immense amount of disagreements on medical ethics, too. Mm-hmm. So the difference, though, is that because it's institutionalized, that means that there's actually ways to actually support people doing research on specifically medical ethics. Right now, it's everyone's hobby, but there's very few people who are doing it actually as their job, right?
Yeah, I agree. There's ethics is always a gray area, and no matter what area we talk about. But I think it is specifically, especially profound when we talk about ultimately the consciousness, whether in the consciousness whether AGI and artificial AI can develop consciousness or not. There's a very divergent opinion about that. So that's one question. Second is that we talk about government regulation, but just by nature, government is always lagging behind development of technology. Sometimes it can be, will be too late, for that. For example, in the automobile industry, we have the safety belt, which is, the industry pretty much reached consensus. This is a very good thing, but it took about 20 years to enforce that. So, there's ample example of that. So my question is whether that be too late. When you come to AI, the consensus in one of the camp is that probably in 50 to 75 years we're gonna reach that AGI level. But if you take that long to develop any regulation, and then there's a chance that the AI development is not a gradual; it's a step kind of development. So can be overnight, can be from subhuman to superhuman level of development. How are we going to cope with that? So, and another part of that is. And this is truly has to be international cooperation. You give the example of the Chinese doctor, Dr. He, but I have a strong suspicion about that because the Chinese government has done far worse than use CRISPR to change the genetics. All that. I think it is kind of very easily can see this thing fall into kind of a situation of prisoner's dilemma. It's like China, Russia, and United States all compete in developing the AI, and everybody knows whoever comes with the best AI, the super AI, will dominate the world in the future. So, if that case, can the international community come to consensus? And just like nuclear weapon development. How much we can trust about that? How we can cope with that? If we didn't do a good job with the nuclear weapons, how we can do a good job with AI? So those are the.
Well, I think we need to separate out, artificial general intelligence (AGI) as you're calling it, from using AI, the AI of today that actually exists today, that can still be used for an immense amount of good and also can do an immense amount of harm. I think that most of the ethical questions are really about the AI of today that we actually have now. We have to make decisions about right now. And that actually has a huge impact on how society is. I think the questions about artificial general intelligence, that's actually pretty far off, I think.
That is. I know that's the divergence of opinion. But in my opinion, that is, it's very foreseeable. I don't give a high probability in 75 years. So, but a lot of people, including people in Google, in Facebook, they don't think that is the possibility is very remote within that time frame. So if we have that,
we're off for a bit. Can you maybe just condense it down to what one question is you have, and then we'll kind of move on to the next person?
Oh no, then this is fine. You address whatever you feel. It's
Yeah, so I would say I think AGI is kind of a separate issue. We can still talk about it, but I think it's a separate issue from how is it that Facebook's using our data right now with AI, and how is Google doing that right now, and what sorts of things are they putting out into the wild for people to use, and I think that sort of thing really we have very little visibility into. And there's really no institutions that are really there that have any power or teeth. Now, what's going to happen with that, I think, is that at some point we could wait for the government to just step in and do it because there's something really bad that happens. But it'd be better if we found a way to do this before something really bad happens. All right, so let's go on to this next question. Another question here. You want to pick one for me, Sam?
Yeah, Ashish has a good relevant one. Do IRBs often have security consultants? If so, who is considered qualified to decide the ways in which kidney images can be misused? Yeah.
So kidney images don't really come with many security risks, except for things like it's possible. Sometimes what people will do is they'll actually add like a watermark to the image that will actually have identifying information on it. That can happen sometimes. So that can be an issue. But even then, it's hard to see the damage what that would actually do. The one that's actually become much more difficult, there's actually been a large number of papers written about it, and it doesn't have a very good solution, is DNA. DNA can be identified down to a person. You can even figure out a person's last name from their DNA, which is kind of crazy when you think about it. And that is much, much harder to do research on with in a de-identified way. That's why you really can't get very much DNA from patients online. And you can do identified research, but eventually you have to basically trust the researcher not to make that data public and not to do the analyses that allow them to de-identify it. So typically there isn't security consultants that are on there, but IRBs are very informed, or at least they should be, about the different types of risks associated with different types of data. There's a lot of work done on this, and this can actually be part of how they actually will come back to you. They'll say, hey, we're really concerned about this particular security loophole with you releasing this data, so you can't release it. Or what are you going to do to really protect patients from this? And you're thinking it's not going to have a problem, but we think that if this data you're planning to put into public data set could be used to do X, Y, and Z. So that sort of question is certainly a really critical question that arises all the time. And like I said, it's not quite. I don't think they typically need to get a security consultant in, but this stuff is actually a big part of actually the scientific literature of actually figuring out what you're allowed to release and why not, and what you can do with data that you maybe that could actually potentially do harm to people. So people are aware of that when they make those decisions.
Great. Thank you. And then another one from Bruce. Where does transparency come into play for the patients in terms of knowing when AI is a part of the care versus humans alone? Is there something that we can learn from transparency with patients we can apply to other fields when it comes to AI use?
Yeah, so transparency, I think, is something that's actually very important to me. So we're actually publishing in academic papers, and we're transparent about our financial conflicts of interests, and we're also transparent about the data analyses we use. And I'm a physician. Joe Gout, who's my co-author on this, he's a physician too. We take deep personal pride in the work we do, and we will not put something out that we don't think is actually, true. That's just not what we're going to do in that regard. And I wouldn't work with Joe unless he was that way too. So the fact that we're even publishing academic papers about this work before it comes into patients is important. It basically is a type of transparency. We're actually showing and telling people publicly exactly how we built this stuff, and showing exactly how it works and with exactly what accuracy, in a way that makes us vulnerable to being copied. It makes us vulnerable to someone saying that they got a slightly better percentage than us. But in the end, I think that that's important, because that's basically how science advances and people can really trust us. In terms of how it's going to work when it comes into practice, we've spent a lot of time on thinking about how that works. And we're probably going to actually really emphasize that there was AI involved. We have a brand name already picked out called Trusted Kidney. And we think that it's something that actually, patients will come to really care about, because they're going to say, hey, this actually is stuff that's been shown to work better than a pathologist working alone. It's a really good thing you're using it. Thank you. And I think that that's probably the best way to do it, where, you can actually demonstrate very clearly that it adds value in a transparent way, and then be transparent that you're using it. There should really be nothing to hide.
Absolutely. Let's see. Response back from Bruce. Thank you. It does occur to me that many corporations consider many things as trade secrets, which presents challenges.
Yeah, so it is a trade secret. So we don't make the code available there, and for for a whole host of reasons, we don't make the images available to people. So you can, and so it is a trade secret. It's actually protected by a trade secret in that regard. It's not like, and it's not easy to go acquire those images, acquire those annotations. It's not easy to go train the algorithm and to deploy it. So in principle, a person could copy us, but it would take a lot of effort, and have to be well situated next to a university to do it, and access to that data. So all of that stuff is trade secret, but the part that we're actually doing that is transparent is everything I told you. When we use it, we're going to be telling people we're using it, and we're actually publishing the analysis that actually validates it publicly in academic journals. And so that doesn't destroy the trade secret, but it doesn't hide how well we're doing or how poorly we're doing. That's out in public.
Great. And this isn't a question, but a comment from Kirtan, an IRB type system that oversees competing companies with powerful optimizers like Google, Microsoft, and Facebook. Seems like it could be viable, but in case of the artificial general intelligence, you run into a series of additional problems. Attempting to apply IRB to AGI would run into problems. And I know you already kind of addressed that AGI is still so far away, and we're really talking about the AI that we have now, but Kirtan is coming from more of an AGI focused background, is why the comment.
Yeah, I would say AGI is a different beast. I think that if we're talking about, I prefer, instead of calling it AGI, I call it artificial mind. There's a whole host of questions that arise with artificial minds. There's even a point where we have to start wondering if we're ethically treating that artificial mind. Is it okay to turn the computer off, or is that akin to killing it? Those are questions that arise. There's also questions about whether or not it's even possible to have AGI outside of an embodied context. So can it be a disembodied mind? Is that even coherent or possible, or does it actually have to have a body attached to it? So some philosophers argue that it has to be embodied, and once again, that also starts to heighten it. So heighten a lot of the ethical questions, because it's not merely about turning off the software program. Then it's disposing of a body potentially. Now, I don't think that we have good answers for a lot of these. Frankly, I think there's a lot more questions than answers. People can talk about when they think AGI was going to happen, but here's the thing: we don't know how to do it yet. Two, we don't even know how to recognize when we've achieved it. It's possible that we could achieve it, but we just have no way of actually determining if it has a mind. And that's a pretty fundamental problem. And those questions come after the big question of, is this even possible in the first place? And I don't think anyone really knows the answer to any of those three questions. Maybe we will in the future. I'm not entirely sure how we would get there. And I think the reality is, if we ever did get AGI, I think most likely whatever artificial mind we make, it's not going to have consciousness in quite the same way that we have it. It's not going to really have like a sense of self in the same way we have it. I mean, they might have it in a different way, but it might not be something we would easily be able to perceive and reason about, which, whatever it is, then I think we're going to have to think about ethics in a very different way to figure out what the right way to handle that is. So I agree with you. It wouldn't really be solved with IRB alone. I think what would have to be is we have to figure out what this new AGI is, but then hopefully be able to manage it still within an IRB sort of context. I don't see why an IRB wouldn't be helpful in that context. It's just that there's just too many unknowns to know precisely what it would do. But maybe in the future we could. Yeah, I'd never talk with the content. I give talks on that sometimes. Maybe I can talk about that sometime.
Yeah, and thank you for addressing that. And I agree. I actually really thought about this really deeply, and we don't really quite understand where our consciousness or soul comes from. And I believe humans are really good at mechanically recreating really anything that enables humans like us to go underwater, go high speed on land, go into air, go outer space. We can do a lot of amazing things mechanically, but I really doubt that, for absolute true consciousness that's near or is general artificial general intelligence, I don't really know if we can recreate the soul, or as you said, a real true human consciousness.
So philosophers call it like the problem of other minds, right? So I don't know if Alan Turing, most people know about the Turing test, but you can't forget about John Searle in the Chinese room. So the problem is that, when I give talks about this, I really go in depth onto the Turing experiment, also on the Chinese room, and then also look at neuroscience. And you can see that when you start to learn more about neuroscience, it really seems to look that the human brain is a lot like a Chinese room. It doesn't, you can understand all the individual parts, and it's not really clear where consciousness arises from it all. And you can put a computer through a Turing test and it could pass. And in fact, maybe even some sorts of Turing tests computers already have passed. But we're not under any illusion that they're conscious. Consciousness is very different than emulating consciousness. So
mimicking, yeah.
And so how do you bridge that gap? And the problem is that even when it comes to ourselves, the only mind that we directly perceive is our own. I think, therefore I am, as Descartes puts it. We don't really have any way of directly even perceiving another person's mind.
We only know our own bias. Yeah.
And so we overcome that with other humans because we think that we realize they have the same sort of origin that we do, the same ontogeny. And it would be frankly descend into absurdity if we didn't believe everyone else had a mind. And so we have this proper basic belief that everyone else has a mind. But then how does that transfer over to machines? It frankly doesn't. And so we have to have some other way of establishing those other minds that we currently just don't have right now.
And thank you. Going back to the main topic at hand, Sarah Armstrong again. Can you speak more about IRBs are ensuring that they are doing a good job of judging things to be ethical? And just for a wider audience, when we're talking about IRBs, we're talking about institutional review boards.
Yeah, so, there's conferences for IRB boards. There's training workshops for people to do that. And there's a lot of research published on them, too. So people are reading that stuff and doing that. It's like a deeply contemplative effort, right? Can IRBs make mistakes? Of course. But one of the things that really helps is that they don't have conflicts of interest. And they also include people that are completely external to the institution. And they actually have power. So what you'll never get is a situation when IRB says, we have a problem with this study. And then someone steps in from a higher position and says, it doesn't matter what the IRB says, we're going to do it anyways. That just never happens. That alone, even if the IRB was wrong, them doing that would be entirely unethical. Does that make sense? And so they actually have real power. They have teeth in that regard. I mean, they can't like go kill your dog. They can't like, steal your child from you, but they can say you can't do that study. And unless you do it, if you do it and ignore them, you're in serious trouble. I mean, it'll make you unhireable. It's a major ethics violation, and it could even frankly get you thrown in jail if someone gets hurt. So these sorts of things are, those are all the things that really help in a lot of ways. So you don't get into a situation where you're in a power struggle, for example, with an IRB board that's saying one thing and the CEO saying another thing, or a professor. That just never happens because the IRB just has total veto power. Like I said, because there's people that have conflicts of interest, that really helps. If you're the one doing the study, you're not going to be on the IRB board that's judging it. So, if your research is involved, you're not the one judging it. And that separation of concerns is really helpful. It works really well in academic context because, professors, we're all about our own stuff, frankly. We're like herding cats, we disagree with each other all the time. Just because it's another professor doesn't mean we're going to agree with them. In a company context, it becomes a little bit harder, and that's also why, for example, IRB or boards will be, for example, run by another company at times, or they'll be, presided. For pharma companies, IRB boards, they're gonna be, tightly connected to what's going on with the FDA, and there's specific rules that arise with the FDA for those IRB boards too. So all those sorts of things really are there to protect them. Now, do mistakes happen? Of course. But at least that there's people who don't have a conflict of interest, who are looking at it closely, that actually have power to stop things from happening, and there's actually a real negotiation that happens. And in fact, if there was real issues happening, they have the freedom to go public with stuff.
Great, thank you.
To be clear, we don't have that confidence right now with Facebook or Google or any AI company, right? We don't have that. And so, do our IRBs going to be perfect? No. But it's an institutional change that would put all of that into the process, which would be 10 times better than we currently have, right?
Right. It's better to have that layer proactively now than later, before it gets really dangerous and out of control.
Yeah, I think it's the sort of thing that as people understand how it works in medicine, there's an opportunity to start kind of asking, well, why isn't AI working through that way? And it's something that will require governmental involvement to get it started, but it's something that really should be bigger than the government. It really has to be with people saying, hey, I want more than just you to have me sign an unintelligible terms of service. I want to know that what you're doing is actually reviewed by external people to make sure it's ethical.
Mm-hmm. And yet, right, larger than the government and also worldwide agreement. And on that note, we have a very good follow-up from Hisham.
Yeah. First of all, thank you very much for that. It was really interesting. And I just want to circle back a little bit when you talked about consciousness and artificial consciousness, because this is a topic that I'm researching for like 3.5 years. And the thing is, this was created my question because the more that I've read more philosophy books than IT books when I'm researching that. And it gets me taking steps back instead of forward, because I'm finding a lot of other stuff. Like right now, there's a lot of questions about AGI, and my concern now is the AI that we had. And it's not AGI, but we had a lot of issues that before we move on, that we have to go. Like, for example, from the medical world, we've heard about this AI that was putting data for people with pneumonia, and it was suggesting that the best thing to give a better treatment for people with pneumonia is to give them asthma, over their own pneumonia. And the thing is, because the data that was giving to that is like when someone comes with a pneumonia and they already have asthma, they have, like the priority. So they just get, because it's too dangerous, right? And they should have been rushed into the hospital. They should have been rushed into treatment. So the AI understood that as it's a good thing to give a dangerous respiratory problem over another. And to get it in, because no one has fed up the information that this is a bad combination, So I think we lack a lot. Like AI is still a baby learning that stuff, and I think there's a huge disconnection because this is a human bias. I think about it as a human bias. No human thinks that putting a respiratory disease over another one is a good idea, even if it's going to rush you to a better service or a faster one. But we forget to put that into a machine, or it didn't come to our mind. It's as we say, it's a no-brainer, which is one of our biggest biases. That if it's a no-brainer, I don't want to think about it, and I don't think the machine. I would probably, assume that the machine would understand that. And also, I think there's a disconnection between the tech companies and the clients like this. So when they just come and sit with you and say, like, what do you want? I'll create that AI for you. But they don't have that much information. They don't have that medical experience, and they work separately. So the question is, what is your view on trying, in this case, for example, like, how do we create that better connection? Because AI is made for people, but if people do not give their real input and leave it to the tech companies, we're going to have that kind of stuff. And
well,
all that biases,
So I'm applying AI in this space, right? And we haven't had that problem because we're taking a different approach to doing this on some really critical ways. One is that we're not really trying to get the AI to do something grand, like figure out how to treat pneumonia, which is a fairly complex thing to do. We've got a focused thing that's really important for a clinical decision that we really think that AI can do a much more reliable job at than a human could, because it's something that's hard, but it's a focused task. And so, it's interesting how this field worked. When we published our first paper, there's probably about 20 papers looking at glomeruli using AI, in kidneys, all right? Not one of them actually addressed the clinical question we chose. Not one of them was with human kidneys with frozen sections, looking at both glomerulosclerosis and sclerotic glomeruli, which is a key set of questions, that string of things that we really need to be able to answer this question for transplant biology. Not one of them had actually done that. So all of them were solving toy problems. Ours is the first one that was actually solving the problem that mattered for the clinical problem. Now, how did that happen? Well, we each picked the problem. The AI didn't. We did. We picked it because we were physicians, and we knew what the hard problem was, and we knew how to actually bring it to practice and do that. And I think, honestly, the most interesting stuff is really going to be that sort of collaboration, in my opinion, at least for the next 10 years, 20 years. There's going to be a collaboration between real expertise and AI. And it's not going to be something where it's just AI going off and taking people's jobs or whatever. We're doing something without, without actually having experts that are really identifying the key problem to apply it to. And I think that's why our work, even though, our group at the time was very new to image analysis, and in fact, we've been innovated a little bit on the image analysis, but it's not really that groundbreaking in terms of the actual algorithms. But the key insight, the key way it's having a huge impact, is that it's just picking the right problem and applying it. And so, applying it to the wrong problem, you'll get a lot of problems like you just discussed. But applying it to the right problem, you don't. I mean, we're not getting that problem in this now. And part of that, I'll say too, just to give you an example of stuff that we've foreseen, is that there's different types of staining people can do, and there's also different types of artifacts that can happen. There's different types of machines that can be used, and we're actually showing and demonstrating that we're actually validating and showing that the algorithm will work across all of these different things, even if it hasn't been trained on them. And showing that robustness there ends up being really important. Now, you're right that if it wasn't people like us, if it wasn't people who are medical doctors who are really close to all the details here, maybe they wouldn't do that validation. And that would be a problem because they wouldn't really know if it worked or not. And, all I got to say is that's why you really want to keep domain experts in the loop. One thing that I have to say, I'm trained in AI. I have a PhD in computer science. But one thing that a lot of the computer science people I know really annoy me with is when they start acting with a little bit of arrogance towards domain experts. Yeah. That's a real problem. It just undermines so many things because, frankly, you need the domain expert as your champion if you want to bring it to practice. So even if it is really a lot better than them, you really want them to be your friend. And secondly, you're never going to even really know if it's that good unless they're kind of testing it, engaging with it. So I think that sort of kind of arrogant approach to AI is a real major problem. And frankly, I think it's set things back in medicine for easily years, if not decades, in terms of how people, kind of the bad taste in people's mouths it creates when you have people come in with that attitude. Now, like I said, I'm a medical doctor, right? And so that changes things a little bit for me, because I can see there's some real expertise there. And a lot of stuff, I think, that would be a total blindside for a person who is just a pure AI person is just very obvious to me. And I also know how to communicate with medical doctors too. So, the first thing I did when we kind of were thinking about this is I'm not a pathologist. I don't actually look at slides for a living. I'm not a kidney pathologist. Like the reason why we picked this is because there was actually a top leading renal pathologist that wanted to work with us on this. And so that was a huge reason why we went down that path. And as I talked to him, I said, okay, so is this actually going to feed into an actual clinical decision, or is it a toy problem? And it really was going to fit into a real decision in a way that was a real pain point they had. So this is another long story short to say that, I think there's actually quite a bit of low-hanging fruit if you're actually willing to work closely with domain experts to really pick the right problems and apply them correctly. And a lot of the pitfalls you read about those sort of things actually can become really irrelevant when really the right domain expertise is applied. Does that make sense?
Great. Thank you. And then welcome back, gang.
Sorry, my keyboard didn't work, so I couldn't type the question. So if this is okay. What you guys said it totally makes sense to me, because I remember that in the 80s, there was something called expert systems, right? That's where it started the AI whole thing. And now that term, we don't use that. We use AI. But, I think that compared to that time, it seems like nowadays it's still an expert system. It's still
expert systems is different than how most AI works, right? So expert systems are a set of rules, essentially. That's
right. I mean, basically, the first stage of the expert system is that you do talk to the experts, right? You gain that knowledge, all that. But right now, AI to me is kind of a combination of those two. You have like neural networking kind of a thing, feeding data, but also you need that expertise from domain expert to do that. But in terms of the ethics and the risk and the risk of AI, to me is it seems like this area, if this is the direction that AI is moving, basically is in a combination of the neural networks and kind of an algorithm plus the human domain.
Well, I don't know if it's going that direction. I feel like I'm a bit like a voice calling out in the wilderness at times. So we go that direction. I don't know if the field is going that direction. Maybe it is. I don't know.
Yeah. But even you assume that is you're right, and moving that, I think that I feel much comfortable if that's the way. But the thing that I'm worried about is that it may have the thing that for example, the training data right now is mostly supervised training, so you have to spend a lot of time labeling data, everything. And if there's some, in near future, there's a lot of unsupervised training. That means that, the computers and the AI system itself will look at, large quantity of data without human intervention of labeling it, and has much unpredictable outcome from that. For example, the AlphaGo. AlphaGo 1.
Can you help me out? What's your question again? You're losing me.
So my question is that, again, this boundary possibility, do you consider that a possibility, or you just, kind of, pretty high confidence that we are not going to go there? I want to give an example of Google AlphaGo 1 and 2, the difference between those two. And you can see that is a glimpse of what can happen if we move that direction. And how we can cope with that, with a different set of ethics, kind of cope with that.
I mean, I guess I don't really see anything that strongly different, man. I think that you really have to be just as clever about how you test algorithms as you are about how you make them. And you really have to have domain expertise to really understand how to correctly validate algorithms. And so there's always going to be advances on the algorithmic side. But to really know which algorithms are actually working, you're going to have domain expertise to know really how to test them. And I kind of gave some examples here where we actually know about different types of systematic artifacts and errors that can creep in. And we want to know that the algorithm is really robust across those sorts of artifacts, right? And so you're talking about training set issues. Well, that's domain expertise about to make sure our training set actually covers those. To make sure our validation is also across those sorts of variables too. So we can train with one set of variables fixed and then kind of test on different values for those. So there's all sorts of things where, I'm a professor, I'm a scientist. I have PhD students in my group, right? That I'm training how to be scientists using AI. One of the first things that they learn, and it takes them a long time to learn it, is that validation is just as important, if not more important, than actually building a new algorithm. And this is like very deeply non-intuitive for programmers, because programmers are they get it to work and then they're done. The instinct. I mean, you have to kind of teach programmers how to build testing code, and good programmers obviously will build testing code, but the level of testing is, it's something different from there. Just making sure it actually completes and it produces proper output, right? But when you're doing stuff like this, you really have to be clever about how you test it. You want to find out sorts of tests you can do to find out where it fails, and then understand why it fails and improve on it. It's always going to take domain expertise, I think. I'm just not whatever the algorithm is, whether it's using reinforcement learning or it's doing semi-supervised learning instead of just supervised or whatever. And frankly, algorithm is a hybrid approach. It uses semi-supervised learning and supervised anyways. That's already happening. The real fundamental thing is how you test it. And is it a valid test that actually really hits the really key things? So that doesn't really change. Sarah, did you have something to ask about?
Oh, yeah. So I kept typing questions, and
I can see that.
Sango suggested I just actually
Great
ask
questions,
them. So my question is, so when I think about medicine and ethics, the first thing that comes to mind is a lot of stuff that's been talked about is Black patients, especially Black female patients, for instance, like with COVID, are more likely to be misdiagnosed or told that they aren't sick. When they're giving birth, they're more likely to die. So there's clearly an ethical problem with the practice of medicine in the United States. And it sounds like what you're saying is that when it comes to medical research, there are methods like the IRBs to prevent ethical problems. Are there ways that we could borrow those things from medical research to apply to the practice of medicine itself, or how would you face those ethical problems?
Yeah, so first of all, IRBs are not a panacea for everything. They're just one place where there's a major institutional between medical research and AI, right? Mm-hmm. I think we benefit from bringing that in. That wouldn't solve everything, because if everyone's still a friggin' racist and a great system, a lot of racist stuff is going to still happen. If we still live in a very divided society, I'm in St. Louis, okay? Mm-hmm. It's still a segregated city here, man. They set up the city for segregation a long time ago, and people are still segregated. I mean, it's legal to integrate, but we don't. That's how broken and screwed up this world is, right? And so, yeah, is that going to have an impact on people? Of course it is. And is an IRB board going to fix that? No. Not a chance, right?
So you're not going to solve the problem for me right now.
Well, what you can do, what I'd say is that it's got to be a lot of issues. The reason why I brought up the IRB issue is I think that it's something that's really overlooked, and most people in AI don't actually know what it is. Mm-hmm. And it's something that I think is really critical because it's an institutional change. Does that make sense?
Yeah, and it's something that can be borrowed by the tech world. Now,
when it comes to a lot of the issues you raised, it's actually fairly complex what's really going on. It's not always. Now, some cases it really is that, there's a lot of bias there with the actual medical doctors that, it's causing issues. That certainly happens. Okay, I'm not trying to say it doesn't. But a lot of times, it's a systemic effect. There's a lot of stuff going on. Some of it's happening in the hospital. Some of it's actually just stuff happening out there in the wild that's spilling over into the hospital. Mm-hmm. And to really start to make changes, you have to understand. I mean, this is, the word for, I'm a scientist, I'm a medical doctor, but really my identity is as a scientist. Like that comes from the Latin word scientia, which means understanding. Scientists care about understanding. And fundamentally, what's really needed for a lot of these problems is not activism primarily, but really understanding. People to sit down and actually understand what's going on. Where is the failure points? Mm-hmm. And where does the problem lie? Is it just that the hospital is kind of just catching a big mess that started elsewhere? That certainly happens. And then where did that mess start and how do you fix it? Or is it something that's actually in their control they can do something about? And then what can they do? And so for each of the cases you talked about, there's going to be a different analysis. That's what makes it really hard. Does that make sense to you?
Yeah, for sure. No, and it seems like there seems to be a theme, though, of sharing knowledge, understanding things better, and transparency, which can apply to all three of these situations.
Yeah, well, I'm a scientist. I'm an academic. I think that frankly, maybe I think it's kind of silly to mobilize a lot of effort and energy if you don't actually understand what the problem is. Okay, we can say, broadly speaking, yes, there's a problem with systemic racism in this country. That doesn't do anything. We have to know actually what do we do with those issues in a way that can actually make it better, right? And I think we also have to be willing to, pay some cost to make it happen. When I think about this history of St. Louis, people turned their lives upside down to make sure they weren't living next to a black person. Mm-hmm. They would change school districts. They would pick up and move. Mm-hmm. Whenever it hit just 5% of people in a neighborhood got black, then they were like, oh, the neighborhood's going to hell, and they would all leave. Okay? They were really committed to segregation. So, that really kind of makes me turn around and wonder, well, if they were that committed to segregation, how committed am I to integration? Mm-hmm. How committed am I to actually really, having a bigger world? They paid a lot of cost to screw it up. How much of a cost am I willing to do to make it right? Yeah. And, that's a hard question, right? I mean, that means it makes me kind of wonder if it might be costly for me. And I think that's what's been hard about us. I think one thing is that, and by the way, I'm not some raging liberal here. I hope I'm not offending anyone. It's just the issue is that when you study the history of these things, you find out that there's a lot of people who intentionally at times set up a really, messed up system. And sometimes it wasn't intentional. But the question is, what do we do with that? And even if we didn't personally make it that way, maybe it's not our fault per se. Right? That it's this way. I mean, I grew up in California. I didn't grow up in St. Louis. My family was in India during segregation. It's not my family. I'm not responsible personally for how it's screwed up here in St. Louis on that level, right?
But you're responsible for making it better as a human who lives there.
Yeah, but it's my adopted city. Am I going to actually be a citizen in this city, right? A citizen of the city where, maybe I could actually put, let's just say, half as much effort into fixing it that they put into screwing it up. That would be kind of cool, right? Yeah. You think about it that way, it kind of really changes, I think, how we think about those things. So, yes, the medical system is part of it. And I really care about those issues. And frankly, it requires people who are full-time devoted to looking into that. And I'm really thankful that WashU really cares about that. And we've been hiring faculty and investing money in it, and the NIH cares about it, other people do too. But the thing about it is it's far a larger issue than can be handled merely on a medical level, a lot of these things. It really requires understanding where the issue is and doing what we can to understand that and to figure out what needs to be done to fix it. But I think a big part of it, I would say, in almost all cases, this is my opinion, speaking as a private citizen, I think a huge part of it is segregation, how we still live segregated instead of integrated. A lot of these issues would be a lot harder to sustain over the long term if we were all living in the same neighborhoods.
I think actually one last thing, and then I will stop talking, is it sounds like I found another correlation between sort of what medicine and tech have in common, and it's questionable origins, questionable established practices that may be unethical, and yet we want to continue to use these practices but improve them from within. So it's sort of a question of how can we make this thing a more ethical practice.
Yeah, so I think one thing that really helps medicine is that it's done primarily in an academic context, right? So you have people publishing about this stuff, and, it also means that ethical abuses are usually contained, right? they're not that way. So I think one of the challenges for for AI is that you have like these transnational companies that think that they're bigger than countries, frankly, right?
Mm-hmm.
And there isn't really anything like a Hippocratic oath for computer programmers. Not that would solve everything, but there isn't the same sort of professional pride and ethics that medicine has. So that means that you could get away with a lot more stuff, right? And there just isn't strong institutions. So yeah, I mean, I do think there needs to be a higher sense of personal ethics in AI, but I really don't think that that's the extent of it. Because the fact of the matter is, if you're just an engineer at Google who has some ethical questions about what's being done there, what are you going to do? I mean, there's no recourse except for maybe getting yourself fired, right? And that's not good. I mean, at WashU for medicine, it's not that way. There's like actual policies and procedures in place to protect whistleblowers and to encourage it. And like institutions for ethics in medicine are very, very strong. And they're very, very weak in AI. Mm-hmm. And so I think that has to change. Otherwise, there's just no way how individuals can really have an impact.
Thank you.
Great. Thank you, Sarah. And up next is Kirtan.
What am I talking about?
You are on stage to ask a question or have a comment?
Oh, well, mostly I just agree with the assessment that narrow AI, the kind that Microsoft, Facebook, all of that is using right now, probably could use a institutional review board that's just across the industry. Does suffer from the same issues that any institutional review board does, which is cognitive bias. And the question of cognitive bias, how to establish ways of quantifying it, detecting it, feedback mechanisms for teaching people how to de-bias themselves is a complicated proposition.
Yeah, what I would just say is that the institutional component is really important. So what are institutions outlive people, right? They're bigger than individual citizens, individual people. That's why they're like the structures that everything is in. And what I think is really strong about an IRB approach is that it creates a structure for a lot of this other stuff to get figured out. I mean, if there are a large number of IRB boards across the country starting to review these things, all of a sudden they're going to start holding conferences and doing research and trying to figure out this stuff in a way that isn't one company in private trying to figure out with no oversight, but it's a group of people that, don't have conflicts of interest trying to share best practices that are going to affect everyone. It's just a very, very different approach. And then fundamentally, it's better than having it as merely legislation. There's a lot of horse training, all that stuff in it. It's really more about a structure in place by which people can actually build it into a discipline, and they actually have teeth to influence how things are done.
Well, if an organization like MIRI decided to stop fear-mongering about AGI and decided to focus on the narrow optimizer paperclip monsters that actually exist today, then they could do that. Like, there are organizations that could serve that purpose if only they chose to.
Well, yeah, I mean, I also think that I agree with you. I think that's the sort of thing where I think, it's interesting. It's a fairly small group here, but it can have a big influence in a lot of ways. That's why I make time to talk to small groups of thought leaders, right? This is the sort of stuff also that, the Good AI, for example, is kind of like set up a bit like a think tank, really getting the right experts in the room and like building a white paper and like really trying to network with the right people to get them. It's the sort of stuff that it only starts with small groups of people that are really devoted and can really kind of put together quality stuff. It can end up having a very large impact down the line.
Can I get back to a point of view you talk about segregation? So there's I'm from Canada, so we have a different set of problems with we have racism and all, but
yeah, you guys still speak French, for goodness sakes. That's a major problem. No,
what?
Just kidding.
No, I didn't get that. What are you saying?
I'm just picking on it. It's an anti-Canadian joke. You can ignore it.
Believe me, we have a lot of ghosts and skeletons in our closets. But the point is, what I've heard, because I've also have a lot of family, cousins, and people in the United States, and what I've read once about this is like there was a study that segregation in the United States was actually would have begun as an optional thing. So when people were coming, United States was open for immigration long before Canada. So we started in 1970s, where the world was really open at the time. It's the 70s. It's everybody talked about it, but the United States were like open way before that. And when people were coming, and because there's also in Canada you have to speak English before you come, but in the United States there's no official language, so you could come with your own language, and people started segregating by choice because they wanted to live near people that speaks their language, that have the same culture and all. And
I'm not talking about that segregation. I'm talking about community groups. I'm talking about the forced legal segregation that was law from the beginning.
Let me finish. Yeah, let me finish. I'm coming to that. But this is what happened. Like now, all of those areas. Now we know in the United States that this area is for black because they started coming from hundreds of years or whatever. And when things like, and this is according to the study or the documentary that I saw about it as well, is like it started as an optional normally because people took that as a choice. But World War come in, for example, and Asian people, specifically Japanese, were systematically segregated because of what happened in Pearl Harbor. 9/11 happened. The Middle Easterns, Arabs, Muslims were segregated by everybody, by the media and all of this thing because of what happened in 9/11. Now, here's what I'm thinking about. So things are now very polarized when it comes to real segregation, and it became like a systematic thing. We have heard Donald Trump saying that Muslims should have something on their IDs or I don't know, their identification, just like the Nazis made the Jews put that badge on them that says that there's a Jew. But here's the thing. My point is it's rooted into the United States history. How do you see it come to dissolve? Because it sounds like it's really, and now if you want to dissolve it and tell people, okay, go integrate, there's still going to be this kind of but I live in this place. I know these people. They understand me. It doesn't matter that it was optional or not, but they were born into these places. How do we go? I don't know. It sounds very complicated to me. What are your thoughts about it?
I think part of it's just deciding what type of world we want to have. Do we want a world like this, or do we want something better? I think saying the government. Say the government does want to do that. I'm talking now about people. The people who are living. I don't know. Most of them they don't see segregation. They say I'm living in a neighborhood because all of my Arab friends are here, and I know, and we can talk, and there's our Middle Eastern restaurants and all of these things. Why do you want me to go into other places and try to integrate? I'm saying because we had, by the way, just so you know, I know that he's an a-hole and a dictator, but Saddam Hussein once, when he was there, tried to integrate Arab families and Kurdish families for 20-something years. He put people from those neighborhoods to those neighborhoods and tried to mix them together. Once he fell down, people came out with weapons on those families who are living there for 20, 30 years and told them, go out. You understand what I'm talking about? It's not sometimes about what the government wants or what the system wants you to do, but people don't see it that way. I think we're far off from AI, but I think I think it really does come down to, it is what people want. I think, like I said, we have to kind of decide what type of world we want.
But AI
I think you're mixing a couple issues here, because there's a very big difference between immigrants that speak a language living in a particular area and what we're talking about segregation when we talk about it here in the United States, specifically here in St. Louis, for example. There's a different historical context, so it's not really a good analogy. But I'll leave it at that for now because this isn't actually a talk about healing racial divides. So maybe we talk about that how it relates to AI the next time.
My point is this segregation is creating what AI is reading. Because when people have that and they believe in it and they don't want to move, then how can I tell the AI to remove that segregation if it's an option? Besides, is there any way that we can consult an AI, since AI now can analyze people's behavior, to say like, can we do something about it to make these people integrate?
Well, so there is a couple examples where I do know about where when it came to like I forgot which company it was, and it probably doesn't matter. I think it was Google Businesses or something like that, where there was like a systematic bias against actually African American areas in St. Louis. Okay.
Yeah.
There's probably a large number of reasons that was the case. It probably wasn't intentional. It probably just has to do with the way how data was being linked and all of that. Especially if I'm pretty sure it was Google, though I forget, and it kind of doesn't matter because it's just very believable this guy. Maybe it was an app or something, right? Oh, you know what I'm talking about. It was an app. I think that's a classic example where, I think we have to kind of think about what would be good in that sense. I think good AI is a great example of that. I think one way to do it is just have it just going and just reflecting data. And so it just reinforces the biases that are already in the world. The other way to think about it is to think about, well, how do we actually have it have a bit of a nudge to a better world? And so I think that's something that really should be thought about a lot. I think that, it's easy to imagine how that app could be modified so it could, instead of becoming something that reinforced segregation, actually kind of was a nudge against segregation. It's easy to imagine things that could happen. It's just not what was the apps were caring about, the developers were caring about, right? And those are, once again, the sort of things that actually IRB boards could address, right? It could be actually pointed out. They could actually, first of all, ask the question about, hey, how are you going to ensure that doesn't happen? And so they could have been testing and validating it, right? And second, they could have said, like, is there ways that you can actually think about how to use this to address some of these issues? And had them actually thinking about it before they actually deployed it. That could have actually happened. And then it could have become a success story instead of a big fiasco, right? And once again, I think there's ways to do that are equitable, that don't end up just, penalizing people for being in the good neighborhood either, right? So those are big questions. And I think actually there's an opportunity if we're more thoughtful about these things to actually kind of build in a nudge towards the good instead of just becoming a reflector of where things are.
Right. Thank you. And we have up next JB. I believe, my memory serves me right, he's from the U.S. Patent Office and always has great questions and comments. JB, welcome back. Can you hear us?
Go ahead, JB.
JB, we can hear you. Or hear.
So there's a question from Bruce, which is great. You said you mentioned the idea that medicine has strong codes of ethics with IRB, and with IRBs, you might learn something that could work in other fields. There are codes of ethics for computer scientists and developers, depending on what professional organizations one is part of. Perhaps it's not emphasized or required like it is in medicine. CS programs are just starting to require ethics courses. Might this be a good start? I think so, to some extent. I think taking ethics courses is a really good thing to require, but it's not a panacea because you can still take an ethics course and be really unethical in the end, right? I mean, there's nothing that's there. I really think it's important to think beyond what individuals are thinking. Yes, individuals need to be ethical, and if we have a lot of unethical individuals, there's really not much you can do about it, okay? But we need more than merely a lot of ethical individuals. A lot of really ethical people can still do very unethical things when they act in aggregate. And you really need to have ethical structures and ethical institutions that support ethical behavior of individuals. And that's a key place that's neglected in a lot of this discussion in computer science.
Mm-hmm.
So, JB, you want to talk now?
JB, can you hear us? Chat.
I guess he can't hear us.
No, he says he can't hear anything.
It's
Well, maybe he can just still ask the question. Whatever. Any other questions? I'm gonna fall in this close.
great. Let's see.
I can't keep track of what I've answered, what I haven't.
Joshua, are we on time? I know this was supposed to end a half an hour ago, and thank you so much for going over. This is a very interesting and exciting topic. A lot of us have something to ask and say, but yeah, how are we doing on time?
We're okay, yeah. Whenever you guys, if you want to end now, that's okay. If you have a couple more questions, that's okay too.
Cool, thank you. On that note, it's wide open. Any other questions or comments? Comment from Bruce. This has been most helpful. Thank you, Dr. Swamidass. Is it okay to share a couple of your slides in my ethics course?
Yeah, absolutely. If you send me an email, I'll send you a copy of my slides.
Nice. And as you probably saw on the screen, when Bruce said thank you, a bunch of likes were flowing in the screen. So thank you. I'd also like to personally thank you, Joshua. You are a great conduit between medical science and AI science, bringing the IRB practice to the tech world. Yes, developers do what they are hired to do because there are business leaders who need to meet their revenue goals. That is the kind of world we're living right now, and that's what the tech giants are doing. But since AI now that we know, can impact people's health both mentally and physically, we need to see AI beyond the consumer or business solutions and product. Hence, once again, treat the industry like similar to the medical industry, requiring something like IRBs. Could the good AI, a think tank filled with AI industry experts, also turn into an IRB to be determined? And maybe need to talk with Vikram about this. But we have all the talent here to pick apart anything, and especially talk around inclusion, ethics, and is this helpful? Is it empathic? So on that note, we'll wrap this up and head back to the virtual lounge. Thank you, everyone. Thank you, Dr. Joshua Swamidass.
Mm-hmm.